Hello YouTube. I wanted to show you something I've been working on for quite a while now. It started off as a little toy, but has evolved into something pretty sophisticated, and that is my pneumatic air cannon. It uses compressed air. It's actually a piston operated pneumatic cannon. It works really well, and before I show you how well it works, I will show you how it works. So, what I have created here is a nice little cross-section of the internals of the air cannon to show you how it works. Just a little orientation. This is the barrel right here. I cut it off because we don't really need it that long for this. And it extends through this coupling section right here into the piston chamber. This is the copper valve, which you use to control the high pressure air that you put into the gun and how you release it and end up firing it. And this right here is the air reservoir. This is where the bulk of the air is stored that shoots whatever you want to shoot out the barrel. So how this actually works is, first you connect high pressure air here. You open the valve. What that does is let the air in through here. That pushes the piston forward like that up against the barrel. And the piston stays very sealed up against the barrel because the pressure behind the piston is very high and the pressure inside the barrel is 0 or just 1 atmospheric pressure, and so that keeps it pushed very tightly up against the barrel. And then because the piston is not a really tight fit inside the chamber, the air that's coming in still just goes around the piston and then down into the air reservoir. So when you want to fire it, this is what you do. First you close the valve, then you disconnect the air hose, then you point it at whatever you want to shoot at, and then you open the valve, and what that does is dump all the air behind the piston out, and because the pressure here is now very low and the pressure in front is still high, it pushes the piston back like that very quickly. And once that has happened, all the air in the reservoir just goes straight out the barrel. So just to give you guys a little better idea of how this barrel arrangement works, I'll take this off and show you. It's like that. That's the barrel. That screws on like that. Now the hardest part about making one of these things isn't putting all this PVC together, which is fairly straightforward. It's making the piston. I used Bondo, which is a car body filler, and the way I made it is, I know that this piping is 1.5 inches in diameter, so I took a piece of 1.5 inch piping, put some grease on the inside, filled it with Bondo, let it sit, and then it just slid out the next day. It was really nice. Did require a little bit of sanding, but that wasn't too bad. And then I just took gasket rubber and glued it onto the end of the piston, and that works really well, as you can see. It just slides very nice. So up until recently, when I wanted to shoot something a little bit faster than normal, what I would simply do is increase the pressure. But lately I have been wondering whether or not just increasing the size of the air reservoir would make a difference, because as you can see, the air reservoir is fairly small. So what I did is create a bunch of different sizes of air reservoirs, and I'm going to test to see if by simply increasing the size of the air chamber you can increase the distance that you can shoot it. So I have created 4 additional air chambers, making 5 total, including the original, and each one I made gets incrementally bigger. The first one I made is 1.5 times the size of the original. The second one is 2 times, 2.5 times, and then the biggest one is 3 times the volume of the original air chamber. For the test, I'm going to be using 75 psi for all shots to keep it consistent. I'm also going to be using a standard projectile, which is this, which is a big dowel with a hockey puck attached to the end. If I used anything smaller, it would just go 3 miles and I'd never be able to find it. So the hockey puck adds weight, which means it won't go as far. It'll be easier to collect. So what I did is took 3 shots with each of the 5 barrels and plotted the average distance it went. And I got some pretty interesting results. Up until 2.5 times the original volume, there is definitely increase. And using the standard error of the mean, I can see that there really is no difference between 2.5 and 3 times the original size. It's pretty interesting. This means that at one point, at just about 2.5 times the original volume, making the chamber larger doesn't make a difference after that point. And I'm not quite sure why. I think it has to do with the length of the barrel just not being long enough to utilize all the air pressure that's in the chamber. That is a good place to start for a second test if I was going to do one, which I might make another video for. But yeah, so the real question was, can you increase the distance that you shoot a projectile simply by increasing the volume of the air reservoir? And the answer is definitely yes. There's fairly big increases in distance between 1 and 1.5, 1.5 and 2, and 2 and 2.5. I still think it's easier just to increase the pressure in the chamber for a couple of reasons. One is you don't have to create all these extra chambers, and 2 is the larger the tank that you have to screw onto the air cannon adds a lot of weight, so it's hard to hold, and it's also harder to aim that way. So definitely doable, but I think still not the best option.